Okay, this is the last video for chapter 17, and it is on the precipitation and separation of ions. Okay, so if you remember in honors chemistry, this was easy because I just gave you that solubility chart for a double replacement reaction, and basically you would look for if anything besides an S showed up on the chart, and if that happened, then that means a precipitate form. Okay, well that's the small of it. Okay, in this chemistry, and Gen Chem, we're going to look at, okay, let's actually put some numbers to it to say whether something will precipitate out when a double replacement reaction happens. Okay? And we're going to use the same thing that we used for equilibrium. Okay? The solution quotient, just like we did for equilibrium quotient. Okay? And there's three scenarios that can occur. The first one is if Q is bigger than KSP, that means that I will have a solid formation, or a precipitate will form. And that's because I have, well, okay, let me just write it out. So like if, for example, if I have something like PbSO4 dissolving into solution, okay, and if the KSP is equal to the concentration of the lead ion times the concentration of the sulfate ion, okay, this is how much can dissolve in this KSP. If the Q, or the number, is bigger than KSP, that means I can't dissolve any more, which means that the solid will form. Okay? Where if Q is less than KSP, that means I can still get to KSP, which means I can still dissolve more solid. Okay? Where if I have Q is equal to KSP, that means that I'm at a saturated solution, so I can't dissolve anymore. So if you remember, saturated means the max amount of solute within a solution. Okay, so let's look at some examples of what this will look like. So the first question, or the one example I'm going to do is, will precipitate form when I react lead to nitrate and sodium sulfate? Okay, so what you need to realize what you're doing is a double replacement reaction. So if I was to write this out so you can see what I mean by that, you have these two guys, and ultimately what you're doing is you're doing a double replacement reaction. So you have lead sulfate and sodium nitrate. So that's your inside-outside. What you're doing is you're replacing. So then ultimately the question is, will you form lead sulfate? Because if you remember, nitrate is always soluble, so then it's going to be NaNO3. So that'll be aqueous. So ultimately the reaction that you're looking for is lead and sulfate aqueous, and you're asking yourself if you're going to form lead sulfate solid. Okay. Now, you're given two different molarities here, and you'll notice that you're given two different volumes as well. So ultimately, you have to find the concentration of the lead and the sulfate and see if it's greater than, less than, or equal to the KSP for lead sulfate that's provided. Okay? So in order to do that, we need to realize that we're mixing two volumes together. So we're going to have to solve for the moles of both of these, and then resolve for molarity because we've increased the volume that's present. So if I can write these out stepwise, we're going to solve for the moles of the ions, and then we're going to resolve for molarity, and then we can solve for the quotient. Okay, so that's kind of our stepwise what we're going to do here. Okay, so I have 0.1 liters of 8.0 times 10 to the negative third molar. Okay, so I'm going to have So moles of lead, and you're going to realize that it's just a 1-to-1 ratio. Okay, so that's important that you're paying attention, because if you make more ions, you're going to have to multiply it by whatever the coefficient is in front. And it's going to be equal to the 0.10 liter times 8.0 times 10 to the negative third molar. So we get, grab a calculator here. Oh, sorry, I have it right. So I get 8.0 times 10 to the negative fourth moles, and that's of lead. Okay, and then to re-get the concentration for molarity, I need to realize that I'm mixing 0.4 and 0.1, so I'm going to divide it by 0.50 liters. So my new molarity for my lead ion is going to turn out to be 0.0016 molar. And then I'm going to do the same thing for the sulfate ion, because I'm precipitating out lead sulfate. So then I'll say moles of sulfate is equal to 0.40 liters times that 5.0 times 10 to the negative third molar. And the moles that I end up getting are 0.002 moles sulfate. And again, I'm in 5 liters now, so it's 0.50 liters, which gives me a concentration of 0.004 molar sulfate. Okay, so now I have molar of sulfate, I have molar of lead, so now I can solve for Q. So Q is going to be equal to the concentration of the lead ion times the concentration of the sulfate ion. So my lead concentration was 0.0016 molar. Concentration of my sulfate ion was 0.004 molar. So my Q in this instance is 8 times 10 to the negative 6. And if you remember, in our original problem, it gave me the KSP of lead sulfate to be 6.3 times 10 to the negative 7th. So in this case, Q is bigger than KSP, which means I have more salt than the water can hold. So in this case, with the concentrations that I'm given by mixing these two together, I will get a precipitate formed. Which means this reaction does move forward, which means I will have a solid formation. Okay?